Conditional reasoning. In the previous section, I considered reasoning about classes of things, but people also reason about conditionality and causality. These kinds of deductions are usually framed within the context of if-then statements. For example, if you study for an exam, then you will do well. This statement reflects a relationship between a behavior, studying, and an outcome, doing well. It reflects only one direction. There may be other things that affect your doing well. As with categorical reasoning, there are several forms of conditional reasoning. The combination of these forms allows for a variety of valid and not valid statements to be expressed and evaluated. Before describing the different versions of conditional reasoning, consider the components of a conditional reasoning statement. Premise: if A, then B. Premise: A is true. Conclusion: therefore B is true. In the first premise, A is referred to as the antecedent. It is the thing or fact that occurs first. B is referred to as the consequent. The consequent is the thing that happens as a consequence of A being true. Although this might seem causal, it need not be. That is, we do not need to assume that A causes B, only that if A is true, B is true also. It's correlational. The second premise gives information about the antecedent within the premise. In this example, it gives information about the antecedent being true. Modus ponens, affirming the antecedent. A common conditional argument is one in which a relationship is expressed between an antecedent and a consequent, and then one is given information that the antecedent is true. Consider the example below. Premise: if the cat is hungry, then she eats her food. Premise: the cat is hungry. Conclusion: therefore she eats her food. In this case, we are informed that if the cat is hungry, the antecedent, then she eats her food, the consequent. The second premise indicates that she is hungry and thus affirms the antecedent. Thus, it can be concluded that she will eat her food. If you accept these premises, you know that if the cat is hungry, then she eats. This is a straightforward relationship that is often referred to as modus ponens, which in Latin means the mode of affirming that which is true. This deduction is valid. It is easy for most of us to understand because it is consistent with our bias to look for confirmatory evidence, and it is also easy to evaluate because it expresses things in the direction of cause and effect. Although conditional reasoning does not need to be causal, we still tend to think in terms of causal relationships. This chapter will discuss confirmation bias later. Modus tollens, denying the consequent. In the previous example, the statement affirmed the antecedent to allow for a valid deduction. However, imagine the same initial premise and now the second premise denies the consequent. Premise: if the cat is hungry, then she eats her food. Premise: she does not eat her food. Conclusion: therefore the cat is not hungry. In this example, the consequent is that she will eat her food. If that consequent is denied by saying she does not eat her food, then you can deduce the antecedent did not happen. The first premise tells you the relationship between the antecedent and the consequent. If the antecedent occurs, then the consequent must happen. If the consequent did not happen, then it is valid to deduce the antecedent did not happen either. This relationship is more difficult for most people to grasp. It runs counter to the bias to look for confirmatory evidence, even though it is still valid. This form is also known by a Latin name, modus tollens, which means the mode of denying the antecedent. When you affirm the antecedent or deny a consequent, you are carrying out a logically valid form of conditional reasoning. Both of these actions allow for a unique conclusion to be drawn from the premises. However, other premises produce invalid conclusions. For example, the statements below show an example of denying the antecedent. Premise: if the cat is hungry, then she eats her food. Premise: the cat is not hungry. Conclusion: therefore she does not eat her food. In this example, the first premise is the same as the previous cases, but the second premise denies the antecedent by telling us that the cat is not hungry. With this information, you may be tempted to assume that the consequent will not happen either. After all, you are told that if she is hungry, she eats. You then find out she is not hungry, so it is natural to assume that she will not eat as a result. You cannot conclude this, however. The reason is that the first premise only gives us information about what happens with a true antecedent and consequent. It does not tell you information about when the antecedent is not true. In other words, it does not rule out the possibility that the cat could eat her food for other reasons as well. She can eat even if she is not hungry. The cat could eat all the time, 24/7, regardless of hunger, and the first premise is still true. And so, finding out that she is not hungry does not allow you to conclude that she will not eat. You can suspect this, you can possibly infer that it might happen, but you cannot arrive at that conclusion exclusively. Affirming the consequent. The final example is one where you receive information that the consequent is true, just like the preceding example. This one might seem intuitive but is not logically valid. An example is below. Premise: if the cat is hungry, then she eats her food. Premise: the cat eats her food. Conclusion: therefore the cat is hungry. The first premise is the same as the preceding examples and expresses the relationship between the hungry cat and the cat eating her food. The second premise affirms the consequence, that is, you are told that she does in fact eat her food. You may be tempted to infer backwards that the cat must have been hungry. But just like the preceding example, the first premise tells you a directional relationship between the hungry cat and eating, but does not tell you anything at all about other possible antecedents for the cat eating her food. As a result, knowing that she eats her food, affirming the consequent, does not allow for an exclusive conclusion that the cat's hunger, the antecedent, was true. This is also an invalid deduction. Card selection tasks. Some of the most well-known reasoning tasks in the psychological literature are the various card selection tasks. These tasks assess people's ability to evaluate evidence and arrive at deductions. Unlike the categorical and conditional examples given above, in which we might be asked to say whether or not a given conclusion is valid, the card selection tasks ask a subject to arrive at the deduction and to make a choice on the basis of that deduction. In these tasks, subjects are typically given one or more rules to evaluate. The rules refer to the relationship of symbols, letters, numbers, or facts that are presented on two-sided cards. In order to determine whether or not the rule is valid, subjects indicate which cards should be investigated. In this respect, the card selection tasks might have some degree of ecological validity with respect to how deduction is used in everyday thinking. The card task tries to answer the following question. If you are given a series of facts, how do you go about verifying whether or not those facts are true? Confirmation bias. Because these tasks have been so well studied, they have also helped to uncover several biases in human reasoning. The first and most extensive is what I have referred to as the confirmation bias. This bias shows up not only in card selection tasks, but also in other kinds of thinking behavior. A confirmation bias reflects the tendency in humans to search for evidence that confirms our beliefs. This bias is pervasive and ubiquitous. Earlier in this chapter, I discussed an invalid categorical syllogism concerning some doctors being rich. If you believed that doctors were rich, you might show a confirmation bias if you only search for evidence of rich doctors. The confirmation bias would also show up if you tended to downplay or discount information that was inconsistent with your belief or would disconfirm your belief. In other words, even if you did meet a doctor who was not rich, you might downplay that evidence as an anomaly or someone who just wasn't rich yet. We often see evidence of confirmation bias in popular media. In the 1990s, dietary advice strongly suggested the best way to eat healthily and reduce weight was to reduce the amount of fat in the food you ate. There was a heavy emphasis on low-fat foods. At the same time, there was a heavy emphasis on eating high-carbohydrate foods. Plain pasta was good, butter and oil were bad. Although we know now that this advice was not very sound, it had a long-lasting effect on personal health. One of the possible reasons is that when people were avoiding fat, they were avoiding higher calorie and richer foods. This may have given the impression that it was the fat that was causing dietary problems, when in fact it may have been a simple issue of overall consumption. People notice many positive factors when switching to a restricted diet of any kind, such as vegan diets, ketogenic diets, or so-called paleo diets. If you switch to a diet like this and you notice some weight loss, you tend to attribute the weight loss to the specifics of the diet, rather than the general tendency to be more selective. This is a confirmation bias. You believe that eating a high-protein diet will result in weight loss, and you may miss the alternative explanation that a restricted diet of any kind can also result in weight loss. The low-fat diet craze of the 1990s was even more difficult because of the strong but incorrect belief of the equivalency between dietary fat and body fat. It is possible that the surface-level correspondence between these two kinds of fats encouraged people to see a confirmatory match where one was not present. Wason card selection task. The confirmation bias has often been studied with a card selection task. The most well-known example of a card selection task is the one developed by Wason in the 1960s. The most elemental version is shown in Figure 7.6. Subjects are shown 4 cards laid out on a table. Each card can have a number or a letter on each side. Subjects are then given a rule to evaluate and are told to indicate the minimum number of cards to turn over in order to verify whether or not this rule is true. For example, considering the card shown in Figure 7.6, the rule might be: premise, if a card has a vowel on one side, then it has an even number on the other side. Wason card selection task. If a card has a vowel on one side, then it has an even number on the other. So you can see 4 cards lined up that say A, 7, 4, and D. Figure 7.6. This is the standard version of the card selection task. Looking at these cards, which ones would you turn over in order to evaluate this rule? Most people would agree that the first card to turn over would be the one with the A on it. If you turn this card over and there is no even number, then the rule is false. This is straightforward because it is an example of affirming the antecedent. The antecedent in this case is if a card has a vowel on one side, so you can see if that is true with the A card. You turn it over to see if the rule is being followed. In the original studies, Wason also found that people almost always suggested turning over the 4 card in addition to the A card. By turning over the 4 card, subjects were looking to see if there was a vowel on the other side. But this is an example of a confirmation bias, where you look for evidence to confirm the statement. This is also an example of affirming the consequent, which is known to be an invalid form of conditional reasoning. The rule does not specify the entire range of possibilities with respect to even number cards. The even number can occur on the other side of a vowel card, as suggested by the rule, but the rule does not exclude the possibility of an even number occurring on the back of other cards. In fact, the rule would be true even if even numbers occurred on the back of all cards. If every single card shown in this array had an even number on the other side, the rule would be true. Wason argued that the correct solution to this problem is to turn over the A card and also the 7 card. The 7 card looks to disconfirm the rule. This is an example of denying the consequent. If the 7 card has a vowel on the other side, then the rule is false. Wason and others have argued that this confirmation bias can also be described as a matching bias. In other words, subjects tend to match their behavior to the stated hypothesis. How does this matching behavior come about? One possibility is limitations in attention and working memory capacity. Given the statements, it may simply be a less demanding task to pick 2 cards that conform most closely to the hypothesis that was stated. Choosing to turn over a card that tests for denying the consequent requires the consideration of a premise that is not explicitly stated. In order to arrive at this implicitly stated premise, the subject must have sufficient working memory resources to hold the stated premise in mind along with the unstated premise. This is not impossible, but it may not be straightforward. As a result, people tend to choose confirmatory evidence. In some ways, the pervasiveness of confirmation bias may be related to the notion of entrenchment. It is culturally and linguistically entrenched to think in terms of describing something that is. So when a person confirms a hypothesis, they look for evidence that something is true. The resulting search space is smaller and constrained, and there is a direct correspondence between the hypothesis and the evidence. When searching for disconfirmatory evidence, the search space is much larger because people will be searching for something that is not. Goodman and others have argued that what something is not a projectable predicate. Deontic selection tasks. The standard confirmation bias shown in the Wason card selection task does not always play out. Alternative versions of the card selection task can be arranged that are formally equivalent on the surface, but ask the subject to adopt a different perspective. In many cases, a permission schema is easier for subjects to consider. That is, when thinking about categories, it makes sense to think about what something is, but not so much to think about what it is not. An animal can be described as a member of the dog category, but it is not very informative to describe the same animal as not being a member of the fork category or the beverage category. The list of categories for which the animal is not a member is essentially infinite. So, with respect to category membership and reasoning, it is understandable that humans display a confirmation bias. Confirmatory evidence is manageable, whereas disconfirmatory evidence is potentially unmanageable. But when thinking about permission, it is common to think about what you can do and what you cannot do. In fact, this is essentially how we think about permission. Technically, permission is something you are permitted or allowed to do, but we often conceive permission to be freedom from restriction. Speed limits tell us how fast we are permitted to travel, but we tend to consider the ramifications of exceeding the speed limit. The green light at a traffic intersection permits you to drive, but the bigger deal is what happens when the red light comes on and you have to stop. Figure 7.7. This is the deontic version of the card selection task that invokes a permission schema. Deontic selection task. If a person is drinking alcohol, they must be over 19. So you can see 4 cards laid out in the same way, and they say 21, beer, Coke, and 17. Wayson's card selection task can be reconstructed as one requiring permission. This is referred to as a deontic selection task. Figure 7.7 shows an example. In this case, the cards have ages and beverages on either side. Just as in the standard version, subjects are given a rule to evaluate and asked to indicate the minimum number of cards they need to turn over in order to evaluate this rule. In this case, the rule might be, premise, if a person is drinking alcohol, they must be over 19. I'm using 19 here because that's the legal drinking age in Ontario where I live. Different countries have different minimum drinking ages, so just replace that with the age where you live when you consider this example. Subjects rarely fail this task. It is straightforward to realize that you need to check the age of the beer drinker, and you need to check with the 17-year-old who is drinking. Even if you have never been in a scenario where you need to ensure that an establishment or club is following the law, most people know what it means to have permission to legally consume alcohol. Very few subjects show a confirmation bias here. The explanation is that this task appeals to the permission schema. The permission schema limits the number of hypotheses that need to be considered. It is important to note that this task succeeds in eliciting logical behavior, not because it makes it more concrete or realistic, but rather because the permission schema reduces the number of options and makes it easier to consider what violates the rule. Other research has shown the same effects, even with fairly abstract material. Context effects. The deontic selection task shows that perspective and context can affect reasoning behavior as well. For example, in the task shown in Figure 7.7, if you are trying to enforce drinking laws, you check the beer drinker and the 17-year-old, but if you are trying to make sure people who can drink legally are in fact consuming the alcohol, suppose you want to really increase sales, you can imagine checking the 21-year-old to make sure they are actually drinking beer. After all, in this scenario, you may want them to drink beer. Figure 7.8, a modified version of the selection task that can show the effects of local schema and context. The role of schema. If a customer spends more than $100, then they may take a free gift. So you can see the 4 cards arranged. From left to right, it says spend $120, spend $75, received gift, no gift. Several studies have looked at the effect of context more systematically. Figure 7.8 shows an example of 4 cards that have facts about how much a person has spent in the store and whether or not they took a free gift. Subjects are told to evaluate the following rule. Premise: if a customer spends more than $100, they may take a free gift. In addition to just being shown the cards and given the premise, Subjects are then given one of two perspectives. If subjects are given the perspective of a store detective, looking for customers who might be cheating the free gift policy, they tend to choose cards 2 and 3. So 2 is spent $75 and 3 is received gift. In this case, you work for the store and you want to make sure the person who has the free gift spent enough to deserve it, and you also want to make sure the person who did not spend enough to take a free gift did not in fact take one. You don't care about the person who did not take the gift, even if they spent enough, because you are looking out for cheaters. Other subjects are told to assume the perspective of a consumer or customer advocate. In this case, you want to make sure the store is keeping its promise. These subjects turned over cards 1 and 4. So 1 is spend $120 and 4 is no gift. In this case, you are on the side of the customer. You want to make sure the person who spent $120 was indeed offered a free gift, and you want to make sure the person who did not take the free gift was not offered one because he or she did not spend enough. You are less concerned about the person who received the free gift. Summary: deductive reasoning is fairly straightforward to describe in many ways. Deductive tasks generally follow a strict logical form. There are clear cases for deductions that are valid and not valid, and there is a fairly straightforward definition for sound and unsound deductions, and yet, most people have difficulty with deductive reasoning. Deductive reasoning seems to be outside the ability of many people, and as discussed in this chapter, many people reason, make decisions, and solve problems in ways that defy a logical deduction, and yet still succeed in allowing people to accomplish goals. This raises important questions about the role of deductive logic within the psychology of thinking. Several of the upcoming chapters will discuss the psychology of decision-making, probability estimation, and problem solving. Many of the cognitive biases that undermine deductive reasoning will also undermine sound decision-making. But as with deductive reasoning, the evidence suggests that many people still make adaptive and smart decisions despite these biases. Appendix: Solution to the two doors problem. In box 7.1, I presented a logical problem based on a movie. If you watch the movie, Sarah solves the riddle. She says to the guard of the red door, "Would he tell me that this door leads to the castle?" In other words, she asks red, "Would he, blue, tell me that this door, red, leads to the castle?" Red says yes. From this, she is able to determine blue is the right door and red is the wrong door. If you watch the movie clip on YouTube, you will see that she chooses the blue door. When she opens the door, she falls into a trap door and the clip ends. But it's early in the movie, it was still the right door. She solved the riddle. She is able to arrive at this conclusion without knowing who is lying and who is telling the truth. Her reasoning is as follows: if red is telling the truth, then blue is a liar. If blue would say red leads to the castle, it would be a lie. Therefore, red does not lead to the castle. Blue equals castle, red equals death. If red is telling the lie, then blue is telling the truth. It is a lie that blue would say that red leads to the castle. Therefore, blue would say that blue leads to the castle. Therefore, blue equals castle, red equals death.